Leetcode 47, Permutations II. When the input can repeat values, naive permutation search can emit the same ordering many times. The task is to return each distinct arrangement once. Example 2, both entries are 2. Any swap leaves the same list, so there is only one unique permutation. Picture the two ones as labeled copies, blue and red, with a 2 in the pool. Timeline A picks blue for the first slot, leaving red and 2. Timeline B picks red first, leaving blue and 2. If we chase both, we build the same multiset twice, 1, 1, 2, twice. That is duplicate work. Instead of treating every copy separately, count how many of each value you have. At a slot, you only start one branch for the value 1 no matter how many ones are left. Same for 2. That rule is the bouncer at the door. On paper the tree can split twice for 2 ones at the root. We prune the second split, after we already branched on value 1 at this level, another one leading branch is redundant. Cut it early instead of filtering only at the end. Track how many of each value remain. When you place a 1 in the first slot, decrement its count. At the next level the table still shows a 1 and a 2 available, so you open 2 doors there. Same value can appear again later, but you do not open duplicate branches for identical values at the same depth. The frequency map is the source of truth, 2 1s and 1 2 available. The empty prefix at the root is where recursion starts. Every branch spends counts until the multiset is used up. For the first slot we iterate over distinct keys that still have a positive count, 1 and 2. That opens 2 branches, not 3. A third branch for another copy of 1 would repeat the same multiset path, so we prune it before it exists. The bouncer is the key set, not the raw list length. Zoom into the branch that started with 1. After decrementing, the map still has 1 1 and 1 2 left, so we legitimately extend with another 1 or with 2. Each choice updates counts again. One more placement each, only a 2 remains under 1 1, only a 1 remains under 1 2. When all counts hit 0 we have a full permutation. These 2 leaves are distinct results, we would append them to the answer list. After recording leaves, recursion unwinds and counts go back up so we can try siblings. The other top-level choice starts with 2. Only 1s are left in the map, so we chain 2 then 1 1 to reach the third unique ordering. Let n be the length of nums and k the number of distinct values. Time is O of n factorial times n in the worst case. When all entries differ there are n factorial leaves and each recorded permutation copies n elements. At each recursive call we only loop over at most k distinct counts. Since k is at most n, that cost is not written as a separate factor in the headline bound. Duplicates only cut branches, the big O upper bound is unchanged. Auxiliary space is O(n) for recursion depth plus a frequency map of size at most n, excluding the output list which holds you permutations of length n. Pseudocode for Permutations II, use a frequency map and depth first search that grows a path. We will walk each line next. Build a map from each value to how many copies appear in nums. List where we append each finished permutation. Current prefix of chosen values while we search. Nested routine explores choices recursively. Stopping rule, path length reached n, so every slot is filled. Store a snapshot of the path as one answer. Exit the base case. Only iterate values whose remaining count is positive. Take this value as the next slot. Consume one occurrence from the map. Recurse to fill the remaining slots. Undo the decrement before trying another sibling. Remove the last value from the prefix. Entry point, run depth first search from the empty path. Return the list of unique permutations.